Hi everybody, my name is Brooke Armesto and I am a senior elementary education major and special education major at Georgia Southern University, and today I'm presenting to you my 5E lesson plan on insulators versus conductors. In this presentation, you're going to get a complete 5E lesson plan with all the materials covering insulators and conductors, and this is for 5th grade. You're going to get teaching tips and questioning strategies for teaching this topic, accommodation for a diverse group of students, and a few examples of ways that you can incorporate personal and community connections with this lesson. The standard that we're going to be covering in this video is S5P2C, plan and carry out investigations on common materials to determine if they are insulators or conductors of electricity. The objective for this lesson for the students to accomplish is to be able to determine whether a common object is an insulator or conductor of electricity using specific evidence to support their reasoning. The science and engineering practices which will be addressed in this lesson are plan and carry out investigations, developing and using models, analyzing and interpreting data, and constructing explanations and designing solutions. The cross-cutting concepts that will be used in this lesson are systems and system models and cause and effect. To begin this lesson, we're going to start with an engage. In the engage, you are piquing the students' interest and activating prior knowledge. The first thing that we're going to be doing is I will walk into the room and flip on and off the light switch, or you will walk into your classroom and flip on and on your light switch. So the first thing you do is flip the switch, and then you ask students this question: why do the lights turn on and off when I flip the switch? So you would tell the students that in their interactive journals, you would want them to create a sketch to show their thinking and label any parts that they may already know. So give them a little bit of time to do this. And now the students would be creating a sketch to show their thinking, labeling any part they might know. They can color it if they want to, and this will just get you a sense of the students' knowledge that they already have, if they have any knowledge on this topic at all, and see what misconceptions they have, what things they may think that are false. And I have a quote here that says, "It's like magic." That's something that I really wanted to include in order to pique the students' interest. I want to tell them that. This is something that I would say to them right after they are finished with their drawing. I would tell them that, isn't it like magic how lights can turn on and off? It's really cool. Just by flipping this little plastic thing, the whole lights in the room turn off. Why does that happen? So we would ask the students this, bring this up to get them thinking about it. Like, yeah, it really is kind of sounding like magic. Why does that happen? So then the students would share aloud what thinking they had, share their drawings. If you have a Promethean, what it's called, where you can, or document camera, you can have students show their drawings or just hold it up to the class, and then ask the students, what questions do you have about this topic? What do you want to know? What are you interested in finding out after this topic was brought up and sparked in their mind? What do they want to know about it now? After the engage, you move on to the explore. The explore is where students are going to be actually engaging with the phenomenon. So the first thing that we're going to be doing in the explore is testing common household objects in a simple circuit. So when you're doing this lesson, your students should have already learned about simple circuits. So first of all, you can review what a simple circuit is, just a very quick, brief review, 1 or 2 sentences to remind students. A simple circuit has a battery and a bulb, and the electricity flows through the circuit, and all the pieces have to be connected. If one piece connects, the bulb does not light up. That's a really important part that you want to mention, that if a piece is not connecting, or if electricity is not flowing all the way through the circuit, then the bulb will not be lighting up, because that's going to become important later in the lesson. Then you're going to have students interact with a virtual manipulative, fill out a T-chart, and answer some guiding questions. And we're going to go over all of that in just a second. So this is the virtual manipulative that students are going to be exploring. And I have this PowerPoint will be linked in the description of this video, as well as the lesson plan. So when you're in this PowerPoint, you can click on this to open up the virtual manipulative for the students. And they'll be having to work on their Chromebooks. You can do this with a real simple circuit kit as well if you have, but I did not have that. So my students will be working here on their Chromebooks. So this is just a simple circuit with a battery and a bulb and the wires connecting them. So you would have the students take each of these and drag them into here. So the students can work in partners or small groups or independently. I have my students working in small groups, and one student will be controlling the computer, maybe another could be taking the notes, or they can take turns. It depends on however the students want to work, because these are 5th graders. I like to give them a little bit of independence so they can choose how they want to work, whether they want to have one person doing the dragging and one person doing the writing, or if they want to be switching off, but they should all be looking at the computer screen and all be observing what's going on. So basically, the student would just take this, take any of these and drag them into here. So this one is, you can see here, this is the object and this is the name of it. So this is an alloy. They would take the alloy and drag it into here, and the bulb lights up. So they would now record on the T-chart. I guess I should show the T-chart that they're going to be completing while they do this. Here's the T-chart that they will be completing as they work with the virtual manipulative. So they will color in with a marker and color in whether or not the bulb illuminated for each one of these things. So let's go back to the manipulative here. So here the bulb did illuminate. So we can take it back. They would color in that the bulb did illuminate. And now we can move on to the next thing. Let's look at the water now. This is just, you would use plain distilled water if you're doing this in real life. So they move in the water. The bulb does not light up. So they would leave the bulb blink, or they could write X through it. The bulb does not light up. Now we have salt water or brine. The salt water, put it into the simple circuit, and the bulb does light up. And this means that the electricity is flowing all the way through the circuit. Students should be making that connection on their own. You shouldn't make that connection for them. So at this point, you are just walking around and observing as your students are completing this on their own and helping if there's any technical issues. So here we have copper wire. The students put in the copper wire. The bulb illuminates. They color it in. The copper wire allowed electricity to flow through the circuit. Then we have glass. The bulb does not illuminate with the glass. So here they would color in, or they would not color in because it did not illuminate. Now we have wood, a pencil, but this is the wood here. Add the wood to the simple circuit. It does not illuminate. Electricity is not flowing through. Then we have graphite. So this is showing you this is the pencil and this is the lead. Taking out the lead or the graphite. It does illuminate with the graphite. Now we're going to go to the aluminum. It does illuminate with the aluminum, and now the plastic. It does not. And notice that these two are of similar shape we have here. They're similar objects. They're both rulers. Here, these are both pencils. Here, these are both water, but there's slight differences that cause it to illuminate or not illuminate. So that's an important thing to note. Hopefully your students will pick up on that. But again, don't tell them these things. Allow them to pick up on this on their own, because this is an inquiry-based lesson. Let's go back into present mode here. So we just looked at the virtual manipulative that the students will be working on, which again, you can click here to access that. And then they will be recording their responses in these T-charts as they go through the virtual manipulative. And you can click on these as well. This is the one you give to students, and this is a key for you to check. Each of these are hyperlinked to the Google Drive of these. So another thing that's important about this activity is addressing the uncommon vocabulary words. So you want to make sure that here your students are not stumbled by vocabulary, especially if you have English and literature in your classroom. So there's some strange words, or not strange, but just uncommon, unfamiliar words to students. Some examples can be illuminate, graphite, which is the pencil lead. You have to make a point that it's not lead, it's graphite, even though we call it lead. Alloy, and copper wire. So if there's other words in there that you think your students may not be familiar with, you can go over those as well. Just make sure that you do not go over the words insulator or conductor, because this is not the time to do that. You're going to go to that yet. At this point, students should not even have any idea what insulators or conductors are, and not even be making connection to those vocabulary words at all. They're just exploring the concept of electricity being transferred and electricity being blocked. So the final thing, after all of the students complete the virtual manipulative activity, they're going to move on to answering these questions in their interactive science journals, which will get them thinking about what they just experienced. So I'm going to read these questions aloud. Which objects allowed the bulb to light up? Think about the attributes, size, color, shape, hardness, texture, material of these objects. What are some attributes that these objects share? What are some differences? And which objects prevented the light bulb from lighting up? So the same question here again, what are the attributes that they share? What are some differences? And then can you make a prediction about which of these attributes are reasons why those specific materials allow the bulb to light up and others don't? So some attributes, like maybe shape, color, size, did not affect whether or not the light bulb lit up, where some other ones, such as material, whether it's made out of metal, do affect whether the bulb lights up. So you want students to make these connections here. But again, you're not giving them the answers in this part. They're just trying to come up with these answers on their own. And that's okay if they're not getting the correct answers at this point. But you can also use this as a formative assessment to see what their thinking is at this point and see how that can guide the rest of your instruction from here on out. So now we're going to move on to the explain section, where you introduce the vocabulary, make connections, and allow the students to form their own explanations for the phenomena. So the first thing that you do as part of the explain is sharing out the students' answers. The students would be sharing out their answers to the guiding questions. So those questions that we just did here in the interactive science journals, now we go through each question and the students can share their ideas and their thinking. And just some tips here are to call multiple students to share before reacting, and refrain from reacting in a way that confirms whether the students are correct or incorrect. You want the students to be able to bounce ideas off of each other and get a class discussion going. So you don't want to halt that class discussion by saying, oh, great job, correct, because then that prevents any other students from adding on. So you want to refrain from saying incorrect or correct, just saying, interesting, things like that. Who else wants to share? Oh, okay, I see what you're saying. Does anybody else have something else to share? So you want to use those talk moves, and you can also use talk moves such as having students repeat after each other. If you have students who don't really want to share, or maybe students who are not as proficient in English and don't want to say a lot of words, maybe students who are more shy, you can have them repeat after what another student said. You can just have them say whether they agree or not. You can use hand signals with your students, like I agree, I disagree, things like that. And you're going to want to collect their responses on the board. So just take little short notes about what each student is saying to all those different questions. The second part of the explain is now you're going to be introducing the vocabulary word of insulator and conductor. You explain that insulators are materials that block the flow of electricity throughout a circuit, and conductors are materials that allow for the flow of electricity throughout a circuit. So now students should begin to start making the connections and seeing, oh, okay, I see. They should, if they have an idea of what a simple circuit is, they should know that when the bulb lights up, electricity is flowing, and when the bulb is not lit up, electricity is being stopped from flowing. So when the bulb is not lit up, then you have a insulator in the circuit. And when the bulb is lit up, you have a conductor in the circuit. So at this point, students should be making this connection on their own. Again, you're not telling them that connection yet. You're just telling them insulators are this, conductors are this. And then you would ask them these guiding questions again. A second set of guiding questions. And these you would do as a class discussion aloud. These would help students begin to start making the connections with the vocabulary words. So you would ask them, can somebody give me an example from our Explore of a conductor? Out of all the objects we tested, which one do you think is a conductor? How do you know that it's a conductor, and what is your reasoning for picking that one? Does anyone agree or disagree? Which of the other objects are conductors? How do you know? I'm sorry, it says how do you know, but how do you know? You said that, this is an example if your student does say this, you could say, you said that we know it is a conductor because it allows a light bulb to light up. Why is that? What is actually happening in the circuit that is causing the light bulb to light up? This is where you eventually want to get. If your students don't get to here, that's okay, you can bring this up, but you're hoping that students get to this point, and the answer here is that electricity is flowing through the circuit because the conductor allows it to. And then you would repeat all of these questions for insulators. So can someone give me an example from our Explorer of an insulator? Which one do you think is an insulator? How do you know? Why? What's your reasoning? Does anyone agree or disagree? Can you give me some more examples of some insulators? So there's that. Then you want to go back and make connections to your engage. So remember, the engage was with a light switch. So we're going to look at the inside of a light switch. Students will revise their explanation or their drawing, and then we'll write a claim, evidence, reasoning statement as a class. So here is the inside of a light switch. And you can click on here to see the photo bigger. And these links are here as well, so you can show them in your class on the board. So here you have this toggle here that when you turn the toggle, so the toggle is the plastic part in the light switch. When you turn it on or off, this is what you're flipping on or off. And this is the spring that keeps the toggle in the on or the off position. So when you have it turned on, then the electricity is being allowed to flow through the circuit. And when you have it turned off, the electricity is not being allowed to flow through the circuit. So you can show your students the inside of the light switch there, and show the students the inside of the light switch there, and then have them revise their drawing of the inside of the light switch and revise their explanation and include the vocabulary words insulator and conductor. Then finally, students will be writing a claim, evidence, reasoning statement about how we can decide if an object is an insulator or a conductor using a simple circuit. So you pick any object, have the students pick the object, but this one is going to be as a class. So have the students as a class all together pick one object that you guys are going to write a claim, evidence, reasoning statement for. So there's a little document here on claim, evidence, reasoning statements if you've never done one before, and you can click it here to expand it and show it to your students. But here's an example of one that you could do with your class. I know that wood is an insulator. Pencils are made of wood, and when I put my pencil into a simple circuit, the light bulb does not, it says the light bulb does not light bulb. The light bulb does not illuminate. I know that objects that cause the bulb to stay dim are insulators because insulators block the flow of electricity in the circuit, and the bulb cannot illuminate without electricity. So you would, as a class, write a statement such as this one all together. Finally, next we're going to do the elaborate. In the elaborate, you will be helping the students extend their knowledge to new situations and to the real world. So they'll be watching this video. I'm not going to show you guys this video just for time's sake, but if you click on here, it'll bring you to the video in a new tab, and you watch the first 2 minutes of the video. In this video, basically, these students are trying to power this clock. They have a simple circuit powering the clock with a lemon, I believe, and then they are adding themselves into the circuit by holding each of the sides of the little wires and then holding hands and seeing if electricity flows through them. And electricity does end up flowing through them. So we're going to answer or discuss the following questions about the video out loud as a class in order to summarize the video and begin to make connections. So have the students summarize the video to you, and then you're going to ask these questions. So we see that the kids become part of a circuit. Were they able to power the clock? How do you know? So they were able to power the clock, and you know that because you saw the clock change. How do you think the clock got power? Can you explain what the power flow was like in the circuit? Where did it come from and pass through, and where did it go? And it came from the battery, it passed through the students, and it went to the clock, and the clock worked. And the last question is, so if electricity flows through the students, does this mean that the students are conductors or insulators? You want to give the students a second to think about their answer, share, discuss as a class, but it does mean that the students or the kids in the video are conductors of electricity because the electricity is flowing through them. So now, independently, the students should answer the following question in their interactive journals, which is, are humans insulators or conductors of electricity? So they can write a claim, evidence, reasoning statement to do this. And here's an example here. I'm not going to read the whole example up to you, but again, this PowerPoint is linked in the description for you to see. And finally, we'll be discussing the implications of this. So since humans are conductors, and we know that from our claim, evidence, reasoning statement that we just wrote, how does that affect our lives, and what does that mean for us? Hopefully the students will say that this means we need to be careful with touching things that are exposed to electricity because the electricity will pass through our body and electrocute us, something like that. Finally, they'll be doing the evaluate, which is their assessment, demonstrating their knowledge of the newly learned skill. So this is a zoomed in version of the assessment. I didn't include the key in this because I just wanted you to be able to see a zoomed in version since it was really small text. So in the assessment, the students will be showing how they would conduct this experiment to find out if a penny is a conductor or an insulator. So they would here draw, or using these materials that they're given, draw what a simple circuit would look like, how they would set up this experiment with a penny. And then they would explain their picture in words and explain a procedure, how they would use this model to determine whether the penny was a conductor or an insulator. Then then they would go over how she, Aaliyah, who's a student here, how she would know whether the penny is a conductor or an insulator based on the procedure. So what result of the experiment would tell you that it's a conductor? What result would tell you that it's an insulator? And then finally, they would explain the reason that conductors and insulators produce different results. So why do conductors illuminate the bulb and while insulators keep the bulb dim? Finally, for the closure, the students will begin by using their whiteboards and writing down an example of any insulator or conductor that they know and how they know that it is an insulator or conductor. This should be done in a sentence, can include a picture if they want to, and then you can have 5 to 10 students share depending on the time. Then the students would go over the I can statement. So as a class, you'd read the I can statement aloud, which is, I can determine if an object is an insulator or conductor of electricity and use specific evidence to support my reasoning. And students should rate their ability on their chest using a 1 to 3 scale, so 1, 2, 3 on their chest, of whether they feel like they can accomplish whether they have accomplished the I can statement. So 1 being the best and 3 being the least. Finally, you can make a real life connection. I have one example here, which is a phone charger. Phone chargers have metal inside, but they're wrapped in plastic because plastic is an insulator and make sure that the electricity doesn't flow out of the charger and shock them. You can use this example. And another example that you can use is turning on and off an oven or turning on and off a TV, that same type of thing. And I would use the oven example because I have a student in my class who this would be a personal community connection to her, which I'll have later on in the slides. But you can do anything that would be a real life connection for your students. Then I would challenge students when they go home to think about other ways insulators and conductors are used in their house. So now we're going to look at very quickly differentiation. How can this lesson be adjusted to fit specific students' needs? So there are a few ways. The first way is by asking leveled questions. I have a gifted student, I have lots of ELL students, I have students at different levels. So I would ask some questions that are short, some questions that are long, which these long questions can be for my talkative students who have a lot to say, or the short questions can be for maybe some of my ELL students who don't have as wide a range of vocabulary and maybe just want to say a few words to talk about their thinking. And I also have some harder questions and some easier questions. That way students who are at different levels academically can answer questions that will be more pertain to their strengths. And another way that I have differentiation in my lesson is by having students draw their thinking. So I have a student with dyslexia, a student with autism, and my ELS students who all have difficulties with writing, and they can show their thinking much better with drawing. So I have the example in the beginning with the light switch, drawing that, and I have at the end drawing an insulator or conductor, and I have in the assessment as well drawing a simple circuit. So there's a few ways there that those students can show their knowledge. And another way is having my directions being shown in multiple formats. So I'll have the directions posted on the board, I'll have the directions saying them out loud, I'll have the directions in writing on the paper. That way students with all different learning styles can have the directions to them in different ways. And my student with ADHD can have the directions right in front of her because it's difficult for her to remember directions 5 minutes from now after I've already said them out loud, so she can have them in front of her throughout the whole task. My student with dyslexia has difficulty reading the instructions, so she can hear me say them verbally. My ELL student's the same, and my student with autism the same. And finally, I have a student with limited mobility, so I'm making sure that everything around the classroom, there's clear paths around the classroom for her to travel around and get into groups, that everything is at an appropriate height for her to be able to reach because she is in a wheelchair at the moment. She had an injury. So just things like that. And finally, the personal community connections I can make to my students' interests. I have one student who is non-binary in my class, so I'm going to be sure to use gender neutral language when referring to any student in my class to make them feel comfortable, to make them feel like they're not the only student being called them or a gender neutral language. So some examples of gender neutral language that you can use are they, them, my friends, kiddos, scholars, scientists, and the like. And finally, I talked about the oven example. This is for my student number 9 who enjoys cooking, so I can make a personal community connection to her there. And finally, we're going to go over the time contingencies. What can I do if I'm running out of time or I have too much time with this lesson? So if you have extra time, something that you can do as a whole class with extra time is you can ask students to come up with a list of household objects that they may want to know about and predict whether they're conductors or insulators. Then we can look up whether it's a conductor or insulator and see if our prediction was right and come up with a reasoning as to why our predictions made sense or we were flawed in our prediction. Some ways that you can, something that you can do when you have extra time with an individual student is by having them read one of these picture perfect science books. So there's some links here that you can access and they all bring you to an Amazon page with these books that I would have out for my students. And if you're running out of time, instead of showing the video and the elaborate, you could just show a picture and explain what's happening in the picture. That way you don't have to go through a whole entire 2-minute video. They'll still get the information that they need and we'll be able to cut down on time. And that is everything that I have for y'all. These are just the technology that I use and the references I use to create all of the assignments. And again, this will all be linked in the description of this video. And thanks for watching.